Okay.
Testing, 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 testing. Okay, so basically the problem is maximum depth of binary tree. So we have 3, 9, 20, 15, 7. Uh, 3, 9, 20, 15, 7. Right. What we need to do is find the height. So the formula for that is simply 1 plus max of height of left subtree या फिर height of right subtree, whichever is highest, whichever is max. We'll use that subtree's height, because obviously if I have this subtree, this one, or I have this subtree, so I will use the height of this subtree only, no? Then only I can get the longest distance from the root to the leaf node. um, so why the 1 plus? So basically what you're doing essentially is you are taking the height of the node. So in like with respect to binary trees, you can't calculate the edges and say like the height for this tree is 1 2. You The height is calculated like this: 1 2 and 3, so 3 levels, and hence height is 3. So you include the first level, which is the root, and then you take the maximum height of whichever is large, the left one or the right one, right? And you do this for all the levels. And recursively, what backtracking gives you is essentially the height of each subtree, uh, the longer one at each level, and at the end of the day you have a commutative uh, result of the total height of the tree. So if I have 3 9 20 15 7, so if I have the tree as 3 9 20 15 and 7, so what is happening over here is, um, this node is giving me 1 plus the max of 9, or the max of, sorry, 20, okay, 20, 15 7, right? And from here the 9 is giving me the, the base condition for this recursion would be that if we encounter any null root, we know that we have to return 0 from there, because we have reached a point where there is no node present as such, and so there will not be any addition to the height that we are calculating. So in this case the root is not null yet. This has one root, so the 9 will be calculated as 1 plus, and this one has uh, null here, and this also points to null, so the maximum of null and null. So this will, because we have this uh, sub base case that if root is null, then give me 0, right? So this will give me 0, this will also give me 0, so the maximum of these two will be 0, and I will get 1 from this. So here answer will be 1, and in this case we will given 1 plus, the 1 comes from this, and plus the maximum of 15, and the height of maximum of height of 15 or height of 7, and these two are also non null, so this will give me 1 plus null or null ka max, and this also will give me same one plus null or null ka max. So this will give me one, this will give me one, and the maximum this will be one. So this will give me two, right? Uh, since this whole ordeal gave me two, so I will put two over here. This gave me two. This part gave me one. So this part gave me one, and this part gave me two, which was like expected because this has two levels and this has one level, and the maximum of one or two will be two. And since we also have the root, so one plus two will give me three. So the height is three. Very simple question, but you have to understand how the recursion works in this case. So if you do the code for this one, what you have to do is simply just write the base case that uh, if the root is null, so there is no node present, so you simply return nothing. Nothing is zero in this case because you are calculating height at each level, so you will have to return zero, right? And simply return one plus max of max depth of root ka left tree and root ka right tree, not like this, sorry, the height of right tree, not ka right tree, right? So same thing that we did in the dry run. So if I done this, this is like an easy problem, but like it builds the base for how you like traverse through the tree and everything. So that's some methods I think I have. I'm logged in. Yep. So this will have, I think, the if I'm not wrong, I think since we are like traversing all the end nodes here, if I go to description, how many nodes are there? So we have like, let's say, n nodes. So the time complexity becomes O of the number of nodes, and space complexity of one, I think. But like there is like some space complexity for the recursion uh, stack, but we'll ignore in this one. So yeah, otherwise we can also say it's O of n, but we can also say O of one, I guess. Let's see the solution. I see. Let's see this was straight. The solution of n and of height, right? So this is of n number of nodes, as I said, and the height of this binary tree, space complexity. Not sure how this was calculated, but let's see. We can about this. So, space of height of height of tree, number of nodes. In the worst case, in the worst case, it will go to all the in the worst case it will go to the number of nodes, all the nodes, and the best case it will be like a balanced tree. So the worst case looks like this. Skewed tree is like this. It has all the nodes in like one direction, right? This is how it looks like. This is a binary tree, and this is like a skewed binary tree. But yeah, yeah. So there is also iterative approach, right? Okay, okay.